So in this video, I'm going to be showing you guys how I make my aluminum coolant tank. I am replacing my coolant lines, which are plastic. I got the stainless steel ones, and I got a new radiator up front. While I'm replacing all this, I'm constantly thinking of this stupid tank, man. These things always leak. These sensors, and these are aftermarket, so who knows what kind of material they made this out of and how long it'll even last before it gets brittle and cracks. So I'm going to attempt to make an aluminum one with a NPT style level sensor and a modern style cap that is just on the radiators. I think they are 38 mil, which is like 1.25" style radiator cap that is on like all the Subarus, Hondas, Toyotas, all the cars that we know, and you can readily get them caps unlike these. Even though this one works fine, I've never had a problem with it. I have the Subaru engine, so it's a little bit different. My kit came with this adapter. It looks like maybe 1 inch to like 5/8 or something. There's an adapter right there, step down. So directly out of the new tank that I'm gonna make, I'm gonna have that Barbs, so I don't have to have that plastic adapter in there. I'm guessing they just did that because the original tank had that size coming out of it, and if you needed to replace it, they just did that for you, so it actually worked. I'm gonna take this thing off. I got my tools right here ready, and see what it's gonna take to make this thing. Here's the tank. I also took the bracket off that was bolted on the inside of my engine bay. So this is how big I'm gonna make it, 17 by 12 by 12. So for the coolant level sensor, I was looking at, let's see, Go Westies, and they have this little guy, which they have an adapter that goes into their tank right here, and that adapter pretty much replaces this one, so you can see it right there. But on my tank, this is a 1/4 NPT. I'm just gonna have that 1/4 NPT directly into my tank, so this threads right in there. And if you look at their sensor real close, it is the exact same one as this one, which coolant temp level sensor, Detroit diesel, it's 17 bucks. It's the same thing, and this is a 1/4 NPT, like I was just saying. So this will thread directly into that. These are the bungs that I'm gonna use. These are 5/8 bungs, and this one is gonna be smaller because this one has a reducer. This is 5/8, so they're both gonna be 5/8, and I like these because it has a real big weld spot right there, and it's not gonna go through this little part, which I've had happen before on some bungs. So also for the coolant cap, they got this Vibrant. It's a weld-on filler neck, so I'm gonna get that, and that weld-on filler neck will use this radiator cap, which is just a stock Subaru one, 108 kilopascals, which is good for this coolant. So here's my sheet of aluminum, and I have my straight edge over here, and I got a scribe, a line across that obviously, and then cut this thing out. All right, got it cut. The old circular saw. Carbide teeth is the key for this. So should be good now. I'm gonna clean this thing up and then start cutting this down so I can bend it and make a box. My shear is ready, and I'm gonna cut this thing down into pieces that I can bend up, and I'm gonna be using this brake press tooling. So I got some little form pieces. Oh yeah, there's another one over there. And I'm gonna hook this press up, put it in there, and then we'll be able to bend these 90-degree angles that we need. But first, I'm gonna come back over here, and some of you may be wondering why I'm using centimeters, especially since I'm American and since that's not the norm here. But I'm gonna show you exactly why and why it's so freaking convenient. So it's 17 long by 12 high, 12 wide. So to find out the total area of this, you do length times width times height, and that's 17 times 12 times 12, and you get 2.448 centimeters cubed. So that is the total area of this box that I'm making. So 2.448, so basically 2.5 if you like just round, but so we know that is the total area. Dude, my pen's messing up. 2.44 kilograms. You just move the decimal point over because kilo is 1,000, so it's almost gonna weigh 2.5 kilograms. 2.448 milliliters, so it's gonna take 2.44 liters. So we know by the dimensions of this, we know that it is gonna weigh 2.44 kilograms, so we might as well just say 2.5 kilograms, and it's gonna take 2.5 liters of coolant. So by doing it this way, I can kind of determine how much and how beefy my brackets need to be, because I know how much it's going to weigh and I know how much coolant it's going to take, like right off the bat. Same thing with my water tank that I just installed. It is 45 liters, which is super convenient because I know it's going to be 45 kilograms. If I made 2 brackets, so it's going to take 22.25 kilograms for each bracket to hold, and I can kind of tell like how beefy my stuff needs to be because the weight is just instantly converted from the liters because it's water. And it's just, dude, it's so convenient. I don't know if you guys can see this on the camera, but right there and right there, there's like hairline cracks where it's just kind of getting brittle. And aluminum is not going to do that. So there's companies that sell aluminum tanks as well. Go Westy and Rocky Mountain Westy. Kind of stole a couple ideas from them, but I'm going to make this thing perfect for my van, my setup. And the barbs are going to be different sizes than theirs. Also, my coolant level sensor is going to be a little bit different. The pieces are all cut out, and I just marked these. This is the torn up part because I cut this with a circular saw. And I marked this part because when I put this in the press, this is going to bend up, and this will be the inside. So now we're going to take these, come over to the press. I need to put on these little tools, and I'll show you guys how I do that, and then bend these things. All right, guys, so this is a 90-degree press brake tool that I made. Turn this up on the lathe. This diameter fits my press. Has a little set screw. Also has a set screw down there to fit this American style tool. And so basically, push that up on there. Got my little 4mm Allen wrench. That is an M8 set screw. And you just tighten it down, and that's that. So this is the bottom of that 90-degree press brake tool. And it has, again, an American style bottom, which I just use these 2 pieces of steel to kind of cradle this. But obviously this is 90 degrees and I need to turn this, so I'll put something under it so it just don't fall through. Right, so there we go. There is my setup. Made a little 3D printed thing for that valve so it can release and I don't have to use the end of my, you can see they got a little spot that they cut out, which originally fit that, but that cap is a lifesaver. It saves so much time. So now we're gonna get our pieces and them are the marks, and I just line this mark up with this top die, and as I press it, it forms it into that little channel right there, and it basically just forces this piece up. Obviously the press moves around a little bit, so it's not exact, but you want to try to get these bends as best as you can, because then the welding process will be a lot easier and things will actually line up. All right, so you can see how easy it is to press. I'm just doing that with my hand. But I'll move on to this to get a good bend. Right there, it starts to tighten up, so we're done. Take this out, and we have a 90-degree bend. That is literally perfect. You can see these 2 form marks right here, where it kind of forced this to bend. And yeah, I mean, you can tell how hard they were hitting it and how good the bend was. But so yeah, that was one. I'm gonna do the other one. So here are the 2 pieces that I bent up. And now I'm going to put these together and make a box, actually similar to that. I just recently got some stuff in the mail, and I'm going to show you guys what I got and how I'm going to use it. This radiator cap is specific to the Vanagon, specific to this coolant bottle, and I had to get one for mine. So I got this Vibrant radiator. It's like a weld-on filler neck, and I got this one because I read some reviews. So this little barb has a 16th MPT, which I can screw into here. I did look at a Mishimoto one, and it pressed in, and one guy said he had to weld this to that, and I just didn't want to deal with that, so I got this one because I knew this threaded in. This is just a basic, like 38 mil, which I think is 1.25 aluminum. It takes pretty much all the caps that are on, like the cars that you see today, and so yeah, this I can just weld directly onto there. It has that vent, which that's the same as that. So this is the cap I got that fits on this Vibrant filler neck. So this is just a standard like 38 mil cap to a Subaru, and it has 108 kilopascals, which is exactly what this one is. So I got the manual open. So this is the water cooled, and it's the exact same. Apply pressure 0.9 to 1.5 bar. If pressure relief valve opens within this range, a cap is okay. And they got their little cap tester there. So 1.9 to 1.15 This is 108, and 1 bar is 100 kilopascals. So this is right within the range, 108, and the max is 115, and the low is 90. So that's like right in the center. That's perfect. Literally perfect for this. And since this cap is that pressure, I know this one will work because it's literally the exact same. It says that in the manual. And this was also on a Subaru, so I know it will run my Subaru that's in my van right now. And this definitely fits on. I tried it. You got to kind of push hard on it to get it to work. But yeah, we should be good. These Barbs, again, another eBay, just a 5/8 weld on barb that I'm gonna just weld on the side, similar to these. It's the exact same size as that, and obviously it's way smaller than the one that's on there originally, but there's an adapter on my van that converts this down to a 5/8, so I figured I'd just make a 5/8 right to the bottle and get rid of that adapter so I can just go right to 5/8 with no drama. So yeah, just put them right there. We're done. This is off of a Detroit Diesel Series 60, and this was on eBay. I think it was like 17 bucks. So obviously you can see they got that wrap around the stainless, and once this connects that, it works, which is the same style as that. That has 2 prongs on the bottom of the sensor, and if it connects the 2, then you're good. So this is a 1/4 NPT, which I had my brother whip up a 1/4 NPT at his work because they have a lathe there. So that I'm gonna weld right there. Actually, I'm gonna weld over there, and this will screw into that. And obviously you can see the level will be good, which honestly is probably the same as the stock one. So the level's good, and yeah, this just screws right onto there. And since that's a tapered thread, it'll seal. Basically, it's gonna be there like that. All right, that is for the cap. And that is for the bung. There's 2, so there you go. Something about TIG welding aluminum that I found out over like the past couple years that I've been welding is it has to be clean, super clean. And there's also an oxide layer over the aluminum that forms, and you have to break through that. And you break through that by basically scuffing that surface. I just hit it on the wire wheel on the grinder, and then clean this off super good with some acetone on a clean rag. I also hit all these pieces. I hit the front side, back side. I did everything. I also cleaned off my filler rod. I just wiped them down, and a little bit of crap came off of them. But yeah, everything's cleaned off. Everything's ready to go. I even did this vibrant radiator, the bung, did that as well. So everything's clean, everything's good. I just sharpened the tip on my welder, and yeah, we're good to go. So here it is, all put together. Everything's on. Them are just little caps I put on just to keep crap out of it. Some of the welds are good, some of them aren't. It's whatever, as long as it holds. And I did grind this one off. I think I'm gonna take some sandpaper and like go one way and kind of make it look like it's flowing one way, like the green. I know it's aluminum, but so yeah, dude, this is it. There's the coolant bottle in the engine bay. So I think it's kind of close to these spark plug wires. Not super close, but I would like a little bit more room in between there. So this has a huge radius right here, and I think what I'm gonna do is I'm gonna notch that to where it's straight. The original obviously is curved everywhere, and it probably fits this a little bit better. Other than that, I think it looks good. So it kind of makes the engine bay look a little bit more solid. I do have this one, and I've thought about that, and maybe that's a future project. I do like, so if you lift this up, I guess this is an old mount. I don't know, I don't remember what it's for. That rubber grommet, there's another rubber grommet there, and the bottom of this tank sits on them. So it's gonna provide another like support, another way of supporting this whole thing, including these side brackets, and it'll bump them, which is completely fine. And that's good because this cap, you have to push down pretty hard and overcome the spring in there to which is what seals it. But I like that because yeah, it's just more support, more surface area on this tank, and it should definitely hold it there. So I've been cutting and grinding on this for a little while. This is the piece I took out, and as you can see in the corners, I drilled holes and then tried to use that radius. Here's what the bracket I'm thinking is going to look like. I just 45 them corners off real quick. This is just an angle, which is exactly what this is. So that's the original bracket, that's the original bracket, and something along the lines of that. Got my brackets all cut out, and they're pretty much the exact same size as my cardboard is. Alright, so I got these. Now I need to 45 them. There's one. There's two. Alright, so that is it. I need to wipe off them numbers and letters, whatever they are. That's the bracket. The bracket's ready to get tacked on, and I'm going to test fit it on the van. Make sure it's all good. Then tack weld that one on. So this is just a quick tip. If I were to weld this with that Sharpie marker on there, it would stay on there forever. I don't know why that is, but if you weld with that on there and then try to rub it off after, it's like it's baked into it. So if you don't want to see it, definitely get it off before you weld it. Alright, here it is. So I tacked up these. I just tacked up that one, and I did cut this one a little bit shorter so it would clear that. I still got to cut that bracket. It's right in the way. But yeah, man, this thing is sweet. So I got these brackets welded on. So here it is. I did put the bolts on. The nuts are behind it. They're just kind of loose, but it's locating everything. So that is where it's going to live. All right, guys, here we go. I kind of expect to see a leak. So I got the welds all fixed up. I just got an MPC plug in there because I got tired of taking it out when I welded. And yeah, I had to chase these down a couple times, the leaks, but we have some pressure in there. And I've been sitting here testing it, and there are 0 leaks. So now I'm confident that this is ready to be put in the van. So I'm going to get on this and get it installed. Just for fun, I'm testing the stock tank, and the results are not good. It leaks like crazy. Where this connector is, it's not connector, but sensor. It does leak. It leaks out of this hose, which I can't get it to stop leaking. But that is insane. And actually it leaks where the connector goes in the center. It's leaking out here too. Probably at the seal as well, because they always leak. So this thing sucks. All the plastic ones, they always... I remember the original one leaking on my van. So this cap pops off at... It's a little bit... It's about a bar, 100 kilopascals. Shout out to my buddy Pete. He's the one with the Miata, if you've watched this channel for a while. This was like an old forklift harness. Like, I don't know what sensor this connected to, but it fits in this one. And that's pretty much what I needed to hook this thing up. So I'm going to cut this thing off and wire this one up. I honestly have no idea which way this needs wired, like positive, negative, or if it even matters. So I'm just going to wire this up, and if it doesn't work, then I'll take this connector out and I'll pin these opposite way they are now, and I'll just leave this connected. And so yeah, I'm just going to tackle it that way. Got the tank in there, and I got this wired. I still need to put my little clamp on there. So I'm finally going to put some water in my coolant system. There hasn't been water in it for like 2 months. So yeah, I'm just going with distilled water at first. So if there's a leak, it's not a complete disaster. I need to get a funnel. So now we got to bleed this coolant system, and we'll be on our way.